Welcome. This is part 5 over 6 over 7. Part 6 was a small class. I already uploaded. Now, here, some application will go for. Actually, analysis of singly reinforced rectangular section by limit state method is already over. Because only two cases, one for under reinforced, one for over reinforced. That is what is my commitment. But still, this class will help to gain little more knowledge for those who are practicing structural engineers or who want to learn more in structures. Or for students, this is very helpful because this is how examination they give the question. Of course, I mixed some loading, they give simple loading all. So once they understand this question, it will help them a lot. Okay, now, practice questions 1 and 2. Now, I wrote the question. Instead of dictating, I wrote the question here. I decided to write it. Dictating is not required. See, you can read the question here and read the question here. Now I will tell you what is question 1. In question 1, there is a beam of span 6 meter. It simply support beam. Span 6 meter. Cross section given, reinforcement details given. So, you know, you can go for analysis and find MR if required. Okay, then they are given loading. What load? They told in the question the beam is loaded by a point load of 20 kilonewton at center. Now what they want is, they want what maximum external UDL beam can support. That clearly means that 20 kilonewton load applied at center is safe. It is not critical. Suppose that 20 kN load at center is not safe or beyond critical, there is no question of applying further load. So, how much there will be, even after considering 20 kN at center, what BM it will produce, the beam will have capacity, beam cross section, to resist furthermore bending moment. That way you can understand it. Okay, now start solution. Now, solution for 1. Something in the class I told. First you decide unknown. See what they want. They want find what maximum external UDL the beam can resist or carry. So they can tell what maximum external UDL. Some people tell the beam can resist or beam can carry. Sorry, I just deliberately wrote here. No beam is resisting the load. People should understand basic concept. One who sets the paper, he is supposed to have good structural knowledge. I am not blaming them. If the beam is resisting the load, why you want support for the column? Why you want support for the beam? Let them construct the beam and leave it. Why? Whatever load comes, it will resist. And carry. First of all, I have seen so many places, they tell beam is carrying. I will ask them, where it is carrying? From where to where? From India to states it is carrying? Or from one place to other it is carrying? Carrying means what? Taking with it. First of all, the word resist or carry, both are wrong. I am very sorry. What to do? They should change the at least outlook. When they set a question, they should know what they are giving. Okay. So therefore, both are wrong statement. So external UDL, the beam can support. Now you can tell. Support is okay. A question mark. Okay. The question should be what maximum external UDL the beam can support. See, beam is supporting the load. It will receive the load and then it won't resist it. It won't carry it somewhere. It will transfer it to the supporting member. For the beam, maybe columns are supporting. So beam becomes supporting member for those members which are resting on the beam or other loads like wall load, etc. Whereas for the beam, column becomes supporting member, or for column, beam becomes supported member. See, these are all finer points. I hope one fine day they should stop giving these statements of beam can resist, beam can carry, beam can support. When beautiful word is there, why they want to use carry, resist, etc. Okay, done. Not blaming them. At least let them realize the mistake. Now start. Unknown, what is unknown? You write. See, class, what all I tell here, you write. Unknown is a UDL. What UDL? They are asking how much external UDL beam can support. Now write, whatever external UDL you are applying on the beam, finally beam will have a UDL, that UDL plus one more extra UDL is there, its own weight. Suppose you apply externally 10 kN per meter, self weight is 3 kN per meter. Therefore, for the beam, the UDL, finally the UDL will become 10 plus 3, 13 kilonewton per meter. So, but they want that 10 kN per meter. So, what you write? Let WU. This is, U means factored. See, last class I told about it regarding factored load. Go through it. Go to part 6. Study thoroughly and come back. Let WU be factored UDL beam can support including self weight. What you will do is, suppose answer for beam external UDL is 10. You won't get 10 now. You will get 13. Then what you do? Subtract that 3. That's all. Including self weight in kilonewton. Oh, sorry. It is a point load in kilonewton per meter. I will be careful. So unit will be kilonewton per meter UDL. Okay. Now, write what is the final factored load for the beam. Span is 6 meter. See, our UDL unknown is WU for unit length. This is a factored loading. Center, they are applying a point load. How much? 20 kN. Again, go back to last class. See, given in the class, WU you have to find. WU should be known. Why known? Given concentrated load at center is 20 kilonewton. That means service load or working load. Understood. When someone will tell the beam is loaded by a point load of 20 kilonewton, means it is the actual load. It is not factored load. If it is factored load, they should tell it. So since it is not told, universally understood that 20 kilonewton is actual service load or working load. But we want factored load here. Again, if you go to previous class, you can see explanation for this one. Go to that class and come back. I have given so many examples, not money matter, with some building case also I told you, to make it more clear. So, taking partial safety factor gamma F 1.5. This also I told last time. Okay. Factored point load or concentrated load at center WU is applied load is 20 kilonewton. So, beam should finally collapse at what load? 20 into 1.5, 30 kilonewton. Okay, now, therefore, this WU is 30 kilonewton. Now find factored maximum BM, which will be at center. These all I cannot tell now, because you should know, you have good correct idea about SFD BMD. In the YouTube, I uploaded classes for course SFD BMD. More than 100 classes are there. Systematic approach, every case are covered there. Go and study there. Start studying at least now. Factored maximum BM for simple support beam with symmetrical normal loading will be at center. It is WL square by 8 due to UDL. See, small w means UDL. Capital WL by 4 for point load. This I cannot explain in this class. Substitute. Small w, it is our unknown. L square, 6 square by 8 plus, even though you are applying 20 kN, factored load is 30 kN into 6 by 4 kilonewton meter, sagging BM, bottom tension, top compression. That's why steel is here. Okay, now we have to find ultimate MR of the cross section of the beam. Why? Question will come. Why means, go back to last class. Last class I told, whenever strength comes into picture, or whenever somebody is asking how much is the load, how much load carrying capacity, see, not load carrying capacity, load supporting capacity, okay, load supporting capacity, then you should know how much beam cross section can resist. Last time told, or suppose you want to know how much maximum you can eat, you should know how much money is there in your pocket. Right. Given cross section, 230, little more. I changed the sketch, that's why it came to side. First I wrote up to here, 230 by 575, tension 3 bars. I told, see, 3 of 25. Usually I write this way. This time, it is 45, 55, how much? If I take over, I rubbed it, 45, okay, 45. Torque, but this time I am putting 5 because it is not torque, mild steel. Make a note, practically mild steel is not used. So what? If they give torque steel, use torque steel. Don't think this question is mild steel, so I should not study. Some value will change. I decided, so far we never considered mild steel. So limit state method, at least once upon a time, long back, it was used. So give respect to elders, that's why. Okay, this question mild steel, 25. B, 230. D, now you have to calculate, remember, waves 530, 575 minus 45. AST, concrete, FCK, mild steel, FY, XU max by D, right? Now go for ultimate MR calculation. See, now I will not explain anything about ultimate MR because now if you cannot find ultimate MR, you are wasting your time attending my class. So next step will be calculation of ultimate MR. Start. I will tell one by one values. I will use the colors. First, you require XU value. I noted down because, don't worry about here, I solved before the class to save the time. 123.79 millimeter is XU. Then calculate XU max. 280.9 millimeter. Okay, now, okay, I'll continue that side now. I'll go that side. This question is not required now. I'll continue here. Question is not required. I can use this space. Bottom question maintain. Okay, now next step. Compare XU with XU max. I will not waste time. That's all. Under rain post. Your personal note. As it is. If someone will ask, what is going on? Don't attend my class. Last 2 classes so thoroughly explained how to find MR. Follow under rain MR. Happily calculate ultimate MR. You will get ultimate MR of cross section. MU will come 97.99. You can take 98 actually. 99 kilonewton meter is the ultimate MR. First you get in Newton millimeter, convert to KN meter. Now equate, 1 minute, why equate? Again class, I will tell you. Because suppose you are asked to check the, again or not required. Last class I told, not required. Go back. Last time I told when to equate, when to compare. Last class I told. So go back. Whenever unknown is there or whenever they ask maximum load beam can support etc., you should equate maximum BM to MR. So that's all. Equate factored maximum BM to, don't put equal. Once you write equate, you should not write equal. Mathematical problem. To MR of cross section of the beam, we get small w into 6 square by 8 plus plus what here? 30 into 6 by 4 equal to 97.99. You are going to get what? W will come. Not W, the WU, correct? WU, sorry, I told WU here. This general formula, see, this is, okay, small WU, this is WU, because fact limit state method. Okay, not a problem, not an issue. WU, you get, this is WU for limit state. You get the value of WU. It is, how much comes? 11.78 kilonewton per meter. Now write a statement. You write, this is already written here. Let WU be the backward UDL the beam can support, including self-weight in kN per meter. So you write here, this is the maximum possible. You should not apply UDL more than this. The factored UDL for the beam should not exceed this one. It is a limiting value. This is the maximum UDL beam can support, including its self-weight. Okay. Now what do you have to do? Now they want to find what external UDL is there. But before that, they want to find what is the safe external UDL means working load. Now do one thing. Therefore, this is a maximum factored UDL. Maximum permissible UDL. Maximum permissible UDL. Maximum permissible UDL corresponding to service load. Service load equal to 11.78. This time you should not multiply. This time you have to divide by 1.5. It will come 7.85 kilonewton per meter, including self-weight. Including self-weight, because failure or collapse UDL is 11.78. Permissible means safely you can apply, or you can write maximum permissible or safe UDL, or service load or working load. That much you should understand, including self-weight. Now calculate self-weight. Self-weight equal to 0.23 into 0.575. I told earlier 0.575 into 25. That will come 3.31 kilonewton per meter. So now see here, factored UDL, or you can tell failure UDL is actually not failure, it is called collapse, 11.78. Again go to last class. You do not want your building or beam to collapse. So if the beam fails at 11.78, safely you can apply 11.78 by 1.5, 7.85, including self-weight. So self-weight of the beam is 3.31. So last statement, therefore maximum permissible permissible external UDL equal to whatever you got, 7.85 subtract 3.31. It will come 3.0. I hear 4.54 kilonewton per meter. So this much external UDL you can safely apply over the beam. Now see, if you apply 4.54 external UDL with self-weight, it will become how much? 7.85. Then when you multiply 1.5, factored will be 11.78. When you put 11.78 here, the maximum factored BM will be exactly equal to ultimate MR of the cross section. Okay. Now question 1 over. Now I will start question 2. Same, I will write first to save the time. Question 2 I will complete now. Now, solution for practice question 2. I wrote the question here. You can read the question and copy the question. I will tell what is the question. You read it, first read it or write it. There is a cantilever beam of span 1.8 meter. Now, it is already, last time see, already loaded by UDL, they want point load. Now reverse. It is already loaded by UDL of 12 kN per meter in addition to self weight. Cross section given, reinforcement given, but one small twist here, they told steel of yield stress 450 Newton per mm square. At present market, the steel is not there. Some special steel. Suppose you ask them, they can tell. It is little high quality than FP415 or low quality than FP500, or it is FP500 due to some defect. It is found to be little weaker. Instead of a strength of 500, when we test the steel, the strength came only 450. So what? Given 450, solve the question. Okay. Find maximum point load or concentrated load beam can support at the free end. Now, an UDL is already given, so 100% sure the beam can support further load. How much maximum you can apply at the free end? Start. But so this time your unknown is point load. Remember, when you take an unknown, we are equating the bending moment to MR. Bending moment means limit state method. Factored bending moment to ultimate MR. So your bending moment should be factored for analysis. See, design field, I do some other way. When I do practical design, I never factor the loading all. Always in the software all, we give working load. But during the design, then we factor. But analysis, usually this is better. Academic point of view or understanding point of view. Okay. Don't worry about those things. So let, see, capital W, point load, B, factored concentrated load, the beam can support at free end. Okay. There is a UDL of WU per unit length. This UDL, factored UDL and point load together is factored loading. So now, in the question given, UDL on the beam, 12 kN per meter, in addition to self weight. Remember, in addition to self weight means self weight is not added, it is to be added. This I told you earlier. Okay, therefore, you have to calculate self weight. Understood? Excluding self weight. No, understood. This is service load. When someone tells beam is loaded by 12 kN per meter means actual load. Nobody wants the beam to fail at actual load. So if the actual load is 12, the beam should fail or collapse at a higher load. Again, go back to last class. Start. Self weight of the beam, 0.3 into 0.6 into 25, 4.5 kN per meter. So UDL on the beam, including self weight. Remember, this is still service load. Service. Okay. Spelling problem. Okay. This is still service load. Which one? 12 plus 4.5, 16.5 kN per meter. If this is the service load, we want the beam to be able to support a UDL of much higher. So, taking gamma F equal to 1.5, I told last class, as per IS code, factored UDL, this is a load factor. This I told in the last class, go through it. Factored UDL on beam, WU equal to 16.5 into 1.5, 24.75. Means, if you apply a UDL of 12, with self weight it will become 16.5. So beam, you want the beam to collapse at 24.75 kN per meter. So this 12.5 is safely can be applied. Okay, now factored maximum BM. This I will not tell much. For a cantilever, under normal loading, I won't tell always. Sometimes some couples given etc. it will change. Under normal loading, for a cantilever beam, maximum BM will be at the fixed end. Here, see, will be at the fixed end. What you have to do is, don't use formula for cantilever. See how much is the BM looking this side. See, at the fixed end, there will be a reacting moment and vertical reaction. Not required. Go to my class SFD BMD series. So here, bending moment. Directly find how much is the BM. WU into 1.8 and small WU into 1.8 into 1.8 by 2. See here, don't tell clockwise, anti-clockwise. It is this way. See, usually in SFDBMD, I use minus sign. Here no, both are producing hogging. So add those two and then tell that much BM hogging. So I told hogging, top tension, bottom compression. So now bottom is compression edge, XU from here, AST here. That much you can make out. Okay, start. Now, calculation of ultimate MR of cross section. Why you are calculating? See last class. Over. All written here. B 300, small d, 600 minus 50 clear cover minus 25 by 2. D will come. AST calculate M25 concrete 25 FCK. Now see, first time in the class, given steel of yield stress, I made dark 450 Newton per mm square. Class, write a note regarding XU max by D. You should write it. In IS code, for Fy equal to 250 or 415 or 500, all in Newton per mm square, IS code has given the values of XU max by D respectively 0.53, 0.48, 0.46. But they got it from this formula. This we know in the class. I told at that time, if any other Fy is given, you cannot use IS code, use the basic formula. So, write the basic formula for XU max by D, substitute Fy equal to 450 and E value, you get XU max by D 0.469. I told if you are calculating little higher accuracy, third decimal. Okay, done. Now, this is over. Now, you have to go for calculation of ultimate MR. Now, I can rub the question. See, now question is not required, no? 1 minute. Yes, not required. Question is not required. I can rub it down. Start. Now, happily enjoy and find ultimate MR. Nobody should tell how to calculate. Okay, start. Now, this time I am not using color also. XU will, okay, I use color for some reason. First I will put XU using green color. Okay, solve. Your XU will come 284.71 millimeter. Then you calculate XU max. It will come 252.09. Oh, then your XU will be more. So, over reinforced. Therefore, I told what all I told. See here, for future, the green color value, you cannot use it. Take what? Therefore, for all further calculation, take XU equal to XU max. It's here. Take that value. If someone will tell, sir, not clear, don't see my classes. If you cannot see the previous classes, directly come to a particular class and tell not clear means I am helpless. Recently in SFDBMD, one comment came. See, there was a diagram like this. He may be seeing this one. I wrote this value without calculating. Comment came, sir, can you please explain these two values? I want, if he's in front of me, I will tell. I have got better work to do than wasting my time for people who are not interested in study or learning. This is told so many times earlier. Before that class, it was class number 50 or 50 odd. It was told so many times earlier. Therefore, that means he directly came to this class and now he is asking me, what is one? And further comment I would have given. Individual doubts I can't clarify because it becomes difficult for me. Individual doubt I clarify only for the courses conducted by me. Live they come. They can ask any doubt. So far, I never told I will tell next time. Any subject, any chapter, any doubt, any time they can ask. But I will restrict them. Right now ask this subject. Sometimes some people come for doubt clearing earlier during exam time. No problem. I am not bothered. Oh, you are which semester, which subject you want? No, ask your doubt. Okay, leave it now. Now, next step. Therefore, go further. Your ultimate MR will come. Now you have to calculate. 2 293.79 kilonewton meter. Remember, I will tell you a hint for you. That is actually, now green color is not required. Okay, that is actually your limiting value, mu limit. Okay, leave it now. Now, equate factored maximum BM to, no space, right, ultimate MR of cross section. Where is the factored maximum BM? It is here, see. 40 point, little ink has become fade. 40.095 plus 1.8 WU equal to MR is here. 293.79. See, when you equate, both should be in the same unit. That much common sense required. Okay, equated. So you will get, therefore, you get WU. This, I shall use this one. WU will come 140.94 kilonewton. That is what? That is factored concentrated load at free end. But what they want? They want maximum permissible load. Therefore, maximum permissible, or what you can tell? Maximum permissible load at free end, that is working load, equal to 140.94. Remember, you have to divide by 1.5. Why I told 93.96 kilonewton. Okay, now see, last time question, UDL answer, finally we divided, point load we multiplied. This time UDL you multiplied, point load we divided. Why? You think and understand. When you are free, think it. So at the working load, the beam can support maximum load of 93.96 kilonewton. Okay, this will complete class number 5, 6, 7, I think. I don't know. Whatever it is, 7. Now, after this one more part will be there. Then I will go for WA info section, where concepts are more and more. Okay, thank you. Thoroughly study and understand, gain more and more knowledge.